Hello everyone, and this is Jason Gideon, Energy Consultants Group, and I wanted to talk to you today a little bit about snow and solar PV. So what I have here is I have a in-phase microinverter 10 kW roof mount system that we're going to use for our demonstration. So it was March 12th and 13th. We received about 6 inches of snow here in east central Iowa. I just happened to record this data and also have some physical world images of different times of this snow on these modules, just for a reference so that you can see what it looks like. And we're just going to discuss some of the ins and outs on that. This is a little bit of a histogram here. This is about 7 o'clock in the morning to about 7 o'clock at night. And I'm just going to play this real quick so you can see throughout the day what the power output is. Currently right now all of the modules are under snow except for these two fellows right here. And the time and date stamp is right here, so you can use that for your reference. And then the system's power output is right here. So I'll just play this real quick. So depending on a number of factors, such as the color of the module, the tilt angle, azimuth, ambient air temperature, prevailing winds, how much snow is on it, whether it's a light snow or a wet snow, all these factors will determine whether it's going to be a few hours or a few days for your modules to clear themselves off. So they also, when they start producing energy, as seen here in the video, they also start generating their own heat, so that also helps melt off the snow modules. So I got a picture here to show you. I believe the first one is at 10:30, so we will move this back to 10:30, which is, I might not get it right on the money, but be pretty close. There's 10:35, 10:30, close enough. Okay. So this is what the roof looks like. It's pretty much the whole roof. You can kind of see the outline here of the modules all the way up to the ridge, all the way over to the other eave. Got a little notch out there, and you can clearly see these two modules here just happen to not be covered in snow, and those are already putting out about 95 more watts than the ones that do have snow. So it just gives you a frame of reference. So the next image was taken about noon, so I will move this up to noon. Those images will disappear as I click on this, but I'll bring them back. So this is what the roof looks like at noon. So just a few hours later, not even that, significant amount of improvement. A little bit, you see the sun has been trying to poke out a little bit, but still heavy clouds are present, and I believe the temperature was about 16-17 degrees on this day, so it was not terribly warm out. Let's see, the next image is at about 1. So, and I didn't do these at like certain increments. I was just trying to take pictures as I took breaks from the day here in the office. So let's see. So this is what it looks like at about 1. Now you can see that the sun is pretty much completely gone, and it's very heavy overcast, but we still continue to keep seeing improvement. So the advantage is obviously when one module starts opening up a little bit, it starts producing a little more power, thusly a little more heat, and then the snow will melt right off. Let's see, the next image is at about 2, so I will advance this to about 2 o'clock. So you can use a frame of reference from the graph here, and then this is at 2 o'clock. So you can really start seeing which modules have some shading on there. Like this guy right here is this module right here, the second one down, and you can see it's just a little bit of snow on there, but it's obviously enough. Look at the power difference between the one above it and below it. So snow can make a difference, just as soiling can from bird poop, dust, shading from a tree, even shading from a cloud. I've seen arrays half shaded from a cloud on a roof or a ground mount. So it can happen. And then let's see, the next one is going to be just a little bit later there, so we'll go to about 3:30 it was. That's close enough. So this is what it looks like at 3:30. And then the next one is at 5 o'clock. That's going to be way down here. 5 o'clock. And that's what it looks like at 5. Just a little bit left up here, and looks like some of this has not come off because of some damming issues, but I believe it'll be coming off here shortly. And then of course the last picture that was taken was at about 6:43, so I'll get to about 6:40, and you can see, voila, pretty much no snow left on it, and it is getting pretty dark out. So in this case it was basically in one day it was melted off on its own. You of course can I'm going to play this again for you guys. You can of course drag the snow off if you want to. I wouldn't suggest that on a roof, especially a metal roof, but it's definitely an option that you can do. I would just generally let it do its own thing, just from a safety standpoint. Should you have a ground mount, obviously you would have a little more safety luxury there to be able to stand on the ground safely and use an extension pole with a snow bar to be able to drag that snow off. But generally speaking, you don't really have to worry about these such of things, and PV systems can work quite well in cold climates. And a good installer will also calculate the loss from snow depending on what area you're in to further improve your annual output projections, so that there's no surprises there. But this was a good example. We generally don't get snow this late in the season, but this was a good one to pop in real quick and just demonstrate the differences between snow and the power output. Like I said, this is a microinverter site. So as you can see, the way microinverters work are they work in parallel, but they work independently from one another, so that when one gets shaded or have electrical problem or whatever the situation is, it doesn't drag the entire branch circuit, or known in the DC world as a string, down to its lowest common denominator. So if this was a branch circuit, as you can see, it's working independently. If this was a DC string, then let's just say these two groups here were together, then all of them would be operating its lowest common denominator. So microinverters can actually yield you more power than a DC string setup can. And then of course the advantage of an MI is that you have module level information versus on a DC string you would not. So even if you did have a electrical problem, let's say a bypass diode on a DC module or something else like that, or electrical problem, it would be very difficult to ascertain what that issue is and then track it down. So you could test the end of your string to at least narrow it down to which string it is, but if you have, let's say, 14 modules in a string, essentially you're going to be pulling all 14 modules and testing them independently to find out which one's the problem. There's some other methods that can be used to help determine that, like maybe some infrared to maybe find some hot spots, and I won't get into that, but generally speaking, MIs are very reliable and they're really easy to use, and you can see that they have great flexibility over monitoring and control, and it's just a really good solution, especially for snow environments. So I hope you enjoyed this video. If you have any other questions or want to learn any more about solar, you can always visit us at the website at ecgllp.com.